is the title of the torsional stability of fixation methods in basic cervical femoral neck fracture, a biomechanical study, presented by Dr. Chantat Mahaisavirya. Please.
Okay, thank you, Chairman and Co-Chairman, and greetings to the audience. It's my pleasure to be in this section, the faculty research. So my research has been recently published in the title of the torsional stability of fixation method. This one is also the biomechanics study. First of all, we know that the basic cervical femoral neck fracture is a rare presentation, which have the high implant failure rate. There are some report that says that it's up to 50% of the mechanical failure after fixations. The biomechanics study evaluation in the old methods, and usually traditionally ways we do is just only under the loads, under the compression load. So the biomechanic evaluation under the torsional load are lacking. So this study is aimed to compare the biomechanic performance of fixation under the torsion load, which is during the gait of the swing phase. So we generate the finite element models and integrate with the fixation construction. Three construction method was taken. First is the dynamic hip screw. Second is the dynamic hip screw with the anti-rotational screw. And the last one is the short cephalomedullary nail. So the finite element analysis was used to simulate the hip rotation during the gait motion of the swing phase. The summation of the force related to the leg in the swing phase was applied. So the outcome of interest, we are interested in the equivalent one-measure stress, or the EQV, the fragment displacement, and the strain energy density that occurs in our models. So to make the models of the finite element analysis, we created the 50 power ankle type 2 basic cervical neck fracture. Because this fracture is situated in the basic cervical area and has the proper ankles from the anatomical study, we use phonotetrahedral element to generate in our models, and the summation of the muscle force that relate to the swing phase of the hip was applied in the boundary and contact conditions, while the proximal femur was constrained and left the distal path free as to demonstrate the swing phase. And the contact between the cortical and the cancellous bone was established except at the fragment interface to see what happens. So this is our result. In this result, the titanium dynamic hip screw plus with the anti-rotational screw give the less strain with just minimal displacement, only 0.06. While in short cephalomedullary nail construct, demonstrate the highest stress with 2 times displacement compared to the other constructions. Also, the stainless steel is feasible to use with a minimal displacement, but the stress in the implant is not the lowest. So let's move to the strain energy density. We found that the stainless dynamic hip screw construct has the lowest strain energy density around the fracture site and the proximal site, while the cephalomedullary nail demonstrates the highest strain energy density around the fracture site, which is situated in the proximal leg screw. So from our result in the study, the dynamic hip screw or the cephalomedullary nail is viable option as the fixation of the basic cervical femoral neck fracture because the integrity of the lateral wall is intact and quite good. But the dynamic hip screw offers a better interfragmentary compression and rotational stability in the basic cervical femoral neck fracture compared to the other methods. The short cephalomedullary nail construct has about 3 to 6 times higher strain energy density values than those other methods. The strain energy density is the demonstration and the represent of a micro motion and the toggling around the metaphysis and the area of the fixation, which indicates that there is a greater risk for loosening and cutout. So under the torsion load, the dynamic hip screw outperformed the cephalomedullary nail due to the strength of the anti-rotational. And this finding is aligned with the biomechanics study on the surrogate proximal femur under the combined axial load and torsion load, which have been published previously. So in conclusions, From this study, we conclude that the titanium dynamic hip screw combined with the anti-rotational screw provide overall biomechanic advantage than the outer fixation under the torsion load in the basic cervical femoral neck fractures. If we use cephalomedullary nail as the fixation device in this type of fracture, the basic cervical femoral neck fracture, they may increase the risk of the leg screw cutout. Thank you.
Okay, thank you very much.